you'll recall from our discussions in lecture, the electrolytic cells are going to be ones that are not spontaneous. That means we're going to need an external power source in order to get this to go. And that is what this red object here is. This is a power source. Now, hooked up to the terminals, the negative terminal here is the iron electrode. Our negative terminal is the iron electrode. Think about our electrochemistry setups and how we set up our cells. When we have an electrolytic cell, is the negative terminal our anode or our cathode? Think about that. Go back over your notes for this. Our positive terminal here is a graphite electrode. Now, right now, I have both these electrodes submerged in deionized water. I've set my potential for this for this power source to 9 volts. We're going to switch this on and see what happens. When we take observations for this lab, we want to look very closely at the electrodes and see if anything is occurring at the surfaces of those electrodes. Even if there's no reaction occurring, that's just as important as saying that a reaction has occurred. So we'll let this run for a moment and see if we see anything happening. Okay, so this again is with our deionized water. Let's turn the power supply off. We're now going to modify this water a little bit by adding some good old table salt. So this is turned off, so I know it's safe to touch this. I definitely don't want to close the circuit on this on accident. All I'm going to do is add a single scoop of the sodium chloride to my deionized water, at which point it is no longer deionized, because I've just dumped a whole bunch of sodium and chloride ions in here. So we'll set this back into place. And now we're going to see what happens when we switch this on again. We'll give this a minute just like we did before. And we're going to see if we have anything happening at these electrodes. It's important that we take observations here that allow us to justify what we think the products and reactants are for the redox reactions that are occurring. So if we see bubbles forming, we know that one of the products must be a gas. So that's something to keep in mind as we're trying to predict what redox reactions are occurring. Another thing to help us do this is to think about what is actually present in that container, in that solution. We have water, so we know H2O is present. Maybe that's getting involved in the redox. We also have sodium ions, which, being cations, could potentially get reduced. And we have chloride ions, which potentially could get oxidized. So we take a look at what is present and try and decide what is most likely to oxidize and what is most likely to reduce. Okay, let's pause here. Okay. All right, so now we've switched to a new solution. Instead of our deionized water and salt, we now have 0.1 molar potassium iodide. Notice that it's a different color solution. This is what it looks like before we've even turned our device off. We're again going to power on our power supply and see what happens at these electrodes. Take note of any color changes you see, if there's any sort of solids or gases forming at these electrodes, because that's going to help us justify what we think is going on in this redox reaction. So we'll take a few minutes to see what happens as we run the potential through this solution. Might even jiggle it a little bit. so you can see. Some interesting things happen. It might be difficult to see what's happening at our graphite electrode, but there is something changing. Okay, next solution. Now we're taking a look at the sodium sulfate solution, again 0.1 molar. We still have the same setup for our electrodes. We're gonna power this on and take a look at what's happening at our cathode and anode. Remember, this is sodium sulfate in the solution. So we would want to reference our table of reduction potentials to kind of get an idea of what is most likely to get reduced or oxidized in this given situation. We'll take this for another minute or two, and then we'll move on to the last solution. Okay, I think we're good there. We're going to turn this off and move on to the next one. Okay, for our last solution in the electrolytic cells, we have copper 2 sulfate. We're going to switch this on just like we did with the others. Take a look at what happens at these electrodes. I'm going to very carefully turn this. Lift it. Let's get ever so carefully out of the solution. So now we're going to turn this off. Take a look at that iron electrode. So this is our iron electrode after we've taken it out of the solution, so you can get a better look at what has happened to it.